Okay, who is sleeping currently in the room? Okay, no one. So, spot me 2 issues with this image, please. Yes? No, you don't. So, someone else? 2 issues. Yes? Teaching, yes. And? Yes, that's also. And what's the third one? Yes, okay, great. So, if someone is not sleeping, then, okay, we are there. So, who am I? I'm Andras Tevesz, currently working as a security researcher at Kujo AI. I think almost no one knows what Kujo AI is, but that's okay. I am mostly focused on IoT security, IoT research, how can we break stuff, mostly on firmware, and I have some hardware interest as well. I have more than 20 years in IT security. I started with coding, then did go to architecture, did some penetration testing, and also did lots of architecture. My past is interesting, so there was big data, auditing, also reverse engineering. So, who knows this logo? Okay, so, some people. Who knows this logo? Almost 2 people. Okay, this will be a fun presentation. And this one? Okay, some more people. So, essentially the presentation is about how you can connect your Flipper Zero to your home automation system. And the ultimate goal is to check and reach your network and figure out how you can connect to it, because currently these networks are pretty locked down. And there is no solution, no easy solution to connect to them. So, essentially basic understanding that I am providing about 2 protocols, Thread and Matter. Some basic understanding how you can hack your Flipper Zero and add some new features. And also hacking. So where does this come from? Originally, I did conduct a research about Thread, and my main goal was to block TCP connections. So if you have a home IoT device, that device goes through your Thread network, and it goes to the internet. And our goal at the company was to block that because of reasons like if you have a spy camera installed in your home, that's not good if that can communicate to the internet. So if you can block it, that's nice. I found out that there is no real device capable of interacting with Thread networks. Thread is not that new, but somehow there are no hackish devices. Also during the research, I did run into multiple issues like version issues, compiling. I will talk a bit about at the end of the presentation. So, for the 5 people who know Flipper, I won't provide any news. But for the others, this is essentially a multi-tool for geeks. You have seen lots of videos, maybe on YouTube. It's about, you can open garage doors with it if you can catch the traffic. You can also use it to clone a hotel card. For some reasons, hotels don't really like that approach. I am not sure why. You can also use some Bluetooth in that. The Bluetooth implementation is a bit limited. There is also an infrared transceiver, so if you would like, you can use your Flipper Zero to switch on or off your TV or use some other infrared tools. You can also go to a shopping center and switch off all the TVs, for example. That's a nice joke. And for us as hackers, there is an interesting thing here. We can use it as an USB to GPIO, USB to SPI UART or I2C controller. Essentially, for real hardware device hacking, it could be used. There are possibilities to extend it via the GPIO. This is one example. This is the initial Wi-Fi board. So if you plug this into your Flipper Zero, then it can be used to access Wi-Fi networks, like scan it, use it to authenticate Wi-Fi clients, all the fun stuff. And some countries did ban it. I don't know why. Maybe they don't like researchers traveling there. Brazil, for example, definitely did ban it, and someone mentioned that Canada did also. I did not validate that, but as I recall, Canada did start to talk about blocking the FlipperZero device. So let's move forward. Let's talk a bit about protocols. There are two interesting things here, and the community currently uses Matter and Thread in a mixed way. So there is Matter and Thread. One is an application level protocol, the other is a network protocol. I will provide a deeper understanding. So this is normally a Matter infrastructure. This normally runs in your home. Maybe you don't really know about it. For example, if you have a HomeKit capable device in your home, then maybe you have a Matter capable device in your home. The providers did start to update the softwares, so some of the Apple stuff does it, some of the Amazon solutions also support it. It's an interesting approach. It's not really picky about networks that it uses. It can be used with Thread, Ethernet, Wi-Fi, or, as you can see on the bottom of the image, with a Thread border router. And it's interesting because this makes love in IoT possible. All these companies, all the huge companies, started to work together. Imagine the case that you have an Alexa and you can tell them that, okay, Alexa, switch on my Google TV. Or, okay, Samsung, whatever, switch on my Nanoleaf. And that works. Because without Matter, this is not possible. Each and every company did create their own ecosystem, and they don't really talk to each other. There are strange solutions like bridges, not really working. But with Matter, everything is unified, and everything works as friendly as possible until you don't try to steal their data. There is a total new story. But let's talk about it near a coffee after this. So, jump to Thread. This is your home if you did buy lots of Thread devices. Thread is a fairly new protocol. 2016 was it originally released or introduced openly. It was created by Google. It uses the same Wi-Fi spectrum as the 2.5 gigahertz Wi-Fi. So if you have a Wi-Fi device, a Zigbee device, and a Thread device, they don't really like each other because they use the same frequency ranges. The new thing about Thread is it's IPv6 based. How many of you know what IPv6 is or use it? Okay, that's way better. So if you plug your Thread network into your home, and your home has IPv6, then these devices can be accessed directly via the IPv6 network. That's a pretty neat thing. Thread is essentially a derivation of Zigbee. Zigbee is an older protocol, it's mostly proprietary, and it's pretty hard to integrate. It needs a Zigbee controller, and it doesn't really have IPv stack on it. So you can't really directly access the devices via IP. One more thing about Thread is that it's self-healing, and it's pretty energy efficient. So it can be integrated into battery-supported devices, like all the small things. It supports multiple routers. I will talk about that later. And the only issue with Thread is that normally there is one Thread border router in your home. The Thread border router is the connection between your home network and the Thread network. That's the translation. And imagine the case that you could use your FlipperZero and connect to all these devices and start to communicate with them or do more fun stuff. So that was hackers before AirCrackNG was introduced, or when there was no packet injection, sniffing. So you had to figure out the Wi-Fi passwords by hand. You sent in one password, then waited, one password, then waited. Then people started to properly do research, and happy things since then. It's war driving, that's the fun part in Wi-Fi cracking. So, what devices? You might have some Thread-capable devices in your home. Yell me if you know some of these and you own some of these, because all of them contains a thread radio. And it can be enabled, or maybe it's enabled by default. So, some deeper understanding about thread, how it's implemented, and why is it hard to use. So, these are the 4 current versions that are out there in different devices. I try to highlight the main usage. So, Thread 1.1 is used by Amazon, and for some reasons they are not really updating their stuff. There is Thread 1.2 that's mostly stable. It has more features. It's used by most of the devices currently on the market. There is Thread 1.3. It's way better than 1.2. It contains more and more features, like it supports multiple thread border routers properly. They can communicate. But it's not really implemented, because in the IoT world, if you release a new software or a new firmware version, it takes around half a year, 1 year to get to the customers. And there is the new release, the 1.4, that's awesome. But no one uses it, because no one was able to compile it properly, put it in the devices, release it to the customers, and update all the existing devices. To handle that issue, Thread introduced multiple badges. One is the connects with Thread, and one is the Thread certified component. This means that in most of the cases, if you have a Thread device and it has that sticker on it, on the box, then it might work or not. It depends on the version. They are mostly backward compatible. The connects with Thread is a bit misleading because it needs a thread border router. All of these badges should be something like, it needs a thread border router. Before you buy it, check that you have a thread border router. I think they did not introduce that badge so far. There is a small gap between specification, documentation, and source code, and then release source code. That's why all the different versions are out there. My solution is not Thread certified so far, but maybe later it could. So, I talked about a protocol. A protocol normally needs a radio hardware. In this case, I found 3 different chip providers who provide Thread radios and small evaluation boards or SDKs or development kits, whatever. They have different software stacks. I tested all of them. For me, ESP was a bit painful because of how it can be built with the Python environment. Something is always broken, and something is somewhat outdated. There is also the Silicon Lab solution. On that case, you must run a full SDK. It needs more and more components. It downloads 2 or 3 gigabytes of something that will run on your computer to compile a small 1 megabyte firmware. And then there is the Nordic solution. That's my favorite. It has a nice, comfortable environment with an installer. You can use it with VS Code. Debugger is mostly working with that. So developing a firmware with Nordic was the easiest for me. Maybe it's different for you guys, but it worked for me. Okay. So let's talk a bit about thread networks. On the image, you can see how a normal thread network is built. There are the routers. Normally, you would imagine that a router will route traffic. And this is true here, but because this is a mesh network, it needs multiple routers. And those routers are talking to each other. Then there are the end devices. The end devices are only picky, and they are talking only to one router. And that one router provides services to the end devices. These kind of devices can disable their radios to consume energy. So if you have something that needs a battery and uses these device implementations, then it can sleep for, let's say, an hour, then wake up, go to the router and ask for information, messages, what it can handle. And there is the border router. As you can see on the image, it's connected to your Wi-Fi or Ethernet, and it provides internet access to the whole thread network. So if your end device decides that it wants to ping someone on the internet, It needs to connect to its router, then go through the router, and exit via the thread border router, go to the internet. And someone choose the moment to call me. So my pocket is buzzing. Okay. We call it commissioning when you are trying to connect a device to your thread router. We have the border router, as I mentioned earlier, is the gateway between your thread network and your non-thread network. There is the joiner. Essentially, that's your new device you bought at Amazon or your local market. It's normally in a box. You unbox it, and you look at it strangely because how can you connect it to your network? As I mentioned, if you don't know what device it needs, then it's pretty hard to figure out what a border router is in your home and how you can connect to that. Okay, and there is the commissioner. In most of the cases, that's the device who is talking to your known home network and your new device. The new device is mostly accessed via Bluetooth, the home network mostly via Wi-Fi. So, connection. We have the easiest and, let's say, less used solution when you simply building a thread network. You have your OpenThread border router, you have the joiner, and you have an external commissioner. In this case, it could be an internal commissioner, on-thread commissioner, but it's not my use case, so we'll skip that. So external commissioner mostly is my phone. Phone is connected to the thread border router. It tells the thread border router that, okay, someone is willing to join, please open up a window for it to join and provide some data to me. Also, the device goes to the joiner, they talk, and then magically the data that needed by the joiner to access the thread network will be on the joiner's device, and it can join. Okay. There is the other solution, and here is the point where things start to get complicated. We have the Matter solution. Matter calls the things a bit differently. In that case, you have a Matter controller, and you have a thread border router as well, but you have a Wi-Fi access. It's mostly the same, but with different naming conventions and a bit different approach. Matter mostly uses QR codes to authenticate your device, but it supports manual code entering. It also supports Bluetooth discovery, so it's a bit more complicated. Okay. What do you think? Is there another way to connect to your thread network? And I spoiled it, yes. As I mentioned, if you have an external commissioner, somehow the external commissioner must talk to your thread network and your thread border router. That's the joiner thing. You have a joiner password that's known by the external commissioner, and it can be used to open up a joiner window. So it's not that complicated, and it's a bit complicated, but not that useful. But there are datasets I will talk a bit about later. Datasets is essentially the data that's used by all the thread devices. And there is also known network keys. Known network keys can be found on the internet. If you know what you are looking for, then it can be used. Okay, and hopefully the demo will work. I will try to first explain what I am going to do. Okay, so I will have a QR code. The QR code is generated by my device. I printed it for easier use because the Flipper Zero screen is a bit small and I implemented only the numbers there. Then I scan the QR code with the phone. Phone starts to communicate with the thread border router. That's the black one there. Then via Bluetooth, the phone sends the data to the Flipper extension board. Then we get the connection. Okay. And that's the point when I was mentioned that a live demo is needed for this conference. And no one did a live demo, so, or I have not seen one. Okay, it's mostly visible. So, the things that you are going to see, or not see because it's a bit small. First, I am doing a factory reset on my radio thing just to, it can forget all the data. Hopefully the log is visible. So, factory reset did happen. Everything seems to get back to its original state. Now I am trying to use my phone. And I am trying to add the device to the network. Also, I did forget to execute the script. So, the flipper can communicate via UART with the radio, and hopefully it can also set it up, yes. And if I have connected the UART cables, you would see it on the bus pirate, but sorry, currently I missed that. So, I am adding the device and unable to access. Okay. So, unexpected error did happen. I am falling back to the video solution. So, UART, log, flipper 0, phone. First, I do a factory reset on the flipper 0's extension board, and then waiting for the communication. In this demo video, I did connect the UART cable, so it works. Initiated my script that talks to the new radio via UART, and then it prints the pairing code. The pairing code can be used by your phone, and hopefully it joins. On the log you can see that it started to communicate, and because this is not certified device, it shows me an error message, but it was able to connect to the thread network because I used method to commission the device to the thread network. So this is a normal way of doing things. This is how it should work. But in this case, the strange thing is that Flipper is controlling most of the stuff. So we could name it, and we could simply use it. And on the top right side, you had 1 second to see the key and the network name. With those, you can later do the connection. And in this case, you could change the LED. If I had a fourth camera, then I could add the view of the LED there, and you could see how the Flipper's LED is changing. Okay, let's move forward. So, get a bit deeper why this is interesting for us and how it can be used or misused. So, to connect to a thread network, we need a PAN ID. PAN ID is something like a VLAN. It identifies the specific thread network. If you have a huge house with different networks, like your Amazon and Apple thread network is in your home, then they should have different PAN IDs. That's why the PAN is important for your connection. There is also the channel ID. It helps if your radio knows which channel it should use to communicate with the other radios. Otherwise, it will be pretty slow to figure out. Also, there is the network name. I am not sure why that's mandatory for the communication, but it's there. And the good thing is that all of these data can be simply queried with any from any thread network. So if you have my device, you can go there, start a scan, and you can see the PAN ID, the channel ID, and the network name. What else is needed for a connection? Who could guess what's needed? Okay, you guessed correctly, it's a network key. That's unique something, it's a bit long, it's hard to figure out, and also brute forcing is not really feasible because the key is a bit complex. Okay, how can we get channel, PAN, and network name? There is an OpenThread simple API call for that. The easiest one is simply execute, if you have UART access to an OpenThread radio, then execute the OT scan command. It will go and send out a thread beacon. The thread beacon will be recognized by the other thread devices, and they will send you the thread message that, okay, I am here, I have this kind of information about me. I color-coded most of the interesting stuff. PAN is the first. MAC address is not really important for us in this case, but it's the second. Channel is the third. I would like to highlight here that Apple uses the second and third line. So Apple uses the 25th channel for its communication in all the test cases that I did. And there's another connection, or there's another option to query more information about your network. The first works without any thread setup or any connection. The second needs a bit more setup. So in that case, you need to initialize your thread device. It needs to set up itself. Then it can execute a thread discover. It's a bit higher on the protocol layer, so it's a layer 3 message. It sends out a meshscope discover message, and it will get answers via that, after that message, and it contains the name that we need. As I mentioned, the network name is needed for the communication, so we have the network name there. And for convenience, we have the PAN, and we have an extended PAN that contains more data. It's not really used by my use case. I mentioned earlier that there is a thing called thread dataset. If you have a thread device, because of the mesh nature, the thread dataset needs to be on each and every device. Because this is a shared knowledge, it contains all the data, like the thread keys as well. I mentioned that if you found somehow a leaked thread dataset on the internet, they are there, then you can extract the data that you need for connection, or you can simply use your UART access to your thread radio and simply set the dataset. And if you are in the vicinity of the other thread networks, vicinity in this case means 2 to 8 meters. Maybe some radio guys could help to increase that. Originally, Bluetooth started with 1 or 2 meters network access. Currently, I think we are currently at 800 meters or something. So hopefully this range will also be increased later. I color-coded the messages for better understanding. The orange stuff is interesting for us. So that's the network key. That's known by all the devices and should be and can be used for accessing data. I left a bit of time to read. So no one really publicizes private data on the internet, right? Like photos of your child, or your Wi-Fi key, or your thread network key. But yes, we do. Some of the default values are used by some of the providers. If you buy, I really don't want to name, but if you buy a specific thread border router, it uses the default thread keys. Thread team did recognize this issue, and they did implement a protocol to generate random keys. So if you are not setting your keys manually, in the near future, hopefully there will be no thread border routers with easy access, but currently there are. Okay, let's start some hacking. So this is the thread radio that I mentioned. This is a Nordic one. It's a small one, but it needs something to work. First, this is just a hardware. It needs a software. There is a stack called ZephyrOS. You can create your application in ZephyrOS. It supports some things like It initializes the thread network for you, and you can use all the underlying protocols. So it's something like a dumbed down OS version for small devices, like IoT devices. It has its own issues. At the end of the presentation, I will show you some of them. So you did buy this device, you did cut the proper cable there and solder the other one. This is needed because we want to power the device from our flipper and don't want to use our USB to power up the device. It looks like so it doesn't look very well if it's not powered by your Flipper Zero. Okay, you soldered it, you created the firmware, and that's the product. It's ugly as hell, but it works. All the probes are for debugging, and this can be used to access your thread network. So some wiring, if you are interested. I did create this slide because it's pretty easy to connect an almost ready device to your Flipper Zero. When I started to investigate, I figured that, okay, I will need to create complex protocols and code everything and then do it on Flipper, do it on firmware, and then connect them and figure it out. Then it struck me that UART based on text, pretty simple to connect. You need two cables. As I mentioned, you use the green one to connect power, ground, and that's it. Later, if you would like to program the device from the Flipper, then the SVD ports are also needed. If you would like to debug your Flipper Zero during the development of your Flipper application, then the blue lines are needed, and that needs also some configuration. If you mess it up, you can break your Flipper. I did it 8 times, but with a proper debugger, you can recover from that. Without a G-Link debugger, you can't really recover from that. So take it easy. There is an option on the radio or on the Nordic device that it can handle NFCs. NFC is important for us because for matter commissioning, NFC could be used. So I don't have to scan the QR code. That did not work. I could touch my phone to the Flipper and then it would initiate the setup with NFC. However, that NFC is not implemented yet. Maybe later. Okay, so next demo. And this is not going to work, so I am not starting to try it. We have the Flipper Zero device, we have a thread border router, and we have an OpenThread device. All of them are presented on the table. First, we initiate the thread discover message, so we can get out the PAN, the network key, the channel ID. We don't know what's the password, but we know because we did use Matter to export that, and then with that Matter export, we did write it to a file in our Flipper Zero, so essentially we know the password. But without that approach, we could simply use brute force to try and iterate over the passwords that we know, like the default ones. Okay, next step. If you connect it to your thread network with Flipper, you could start to ping the different devices in your network. If they respond, then you are happy because your connection is stable and working. And here comes the interesting part. You can ping things on the internet. So via Flipper, we can ping Google's DNS server and it responds. And all the data is going through the thread network. It reaches the thread border router, then exits to your home network, then exits to your home CP, then it goes through the internet, and then it goes to Google. And you get a response. That's another funny thing. It works with IPv4 because there is a thing called network address translation happening on some of the border routers, but it works best with IPv6. And also we can do port scanning. Port scanning is useful because you know what ports are accessible for you. Imagine that you are using a Flipper Zero with this radio, you are sitting in a house, you connect it to a thread network for some reason, like you're trying to figure out what's in your thread network, and then you start to port scan all the devices. With that port scan, you can figure out that all your light switches provide open ports via IPv6 that can be accessed from your home. it might be useful. Or you can simply port scan someone on the internet. That's another approach, that's another use case. And also, you can create a tunnel. So it's a bit complicated and it was really hard to visualize it on the slide, but essentially it happens that our flipper is connected to someone in the network, in your home network. It could be the thread network or it could be your home network. So, for example, if you have a vulnerable Plex device, that vulnerable Plex device TCP port could be forwarded to someone on the internet. And that someone on the internet could directly access your Plex device. That's an example. Okay, and this is the demo that tries to go to all the things that I mentioned earlier. So we have the flipper log, we have the external host, that's the attacker's port that's listening on the internet, and that's the malicious code that will run under it. On the right side you can see, so in the middle you can see the logs. That logs are coming from a flipper 0. Essentially I did log the messages that I am communicating between flipper 0 and the thread radio. We did send out a discover message and found the network. Then we did try multiple network configurations, and I am a bit slow, so it connected and ping was initiated. And as you can see on the logs, the ping message was sent and it's not lost, so there is connection. The next one, this is the IPv6 version of the ping. It will also go out, as I mentioned earlier, via the complex route, and the IPv6 ping is also working. That's magical. Okay, next we print some IP addresses. This is interesting because if you know your IP address, you can tell what type of network that IP address is used in IPv6. Okay, initiate the port scan against a public DNS server. And we can figure it out that there is an open HTTPS port. I implemented also a banner grabber, so later it will be used. And the next scan is my local IP address. I am scanning that to figure out what's running on it. I can see that that server is running an SSH drop beer. So if I forward that out for someone, he can start to brute force my SSH server. And I also found an open HTTP and HTTP hash port. With the HTTP, I did a banner grab as well, or not. And now we are executing the port scanning, not the connection, and you have seen on the left side, I was not fast enough, you have seen on the left side that the data was extracted when I executed the tunnel. So everything was going through all those mazes, and then my home network's data ended up somewhere on the internet. No? Okay. Okay, what future we could imagine for this device? Currently, all the things are implemented in JavaScript, running on the flipper 0. It's a pretty limited environment in terms of memory and everything, and it's painful to use, but it's a bit easier to program than the original flipper application API. I started to work with flipper app first, and it was miserable. I did run out of memory, it did fail, it did crash on me, I could not really debug it. When I started to debug it, then I could not connect my device because it needs more and more ports. But it could be used. Hopefully someone will do it later. I am open for committers. There is the SVD integration. Currently, to do the method thing and to the thread thing, I need two devices with two firmwares. With SVD, I could do something like upload firmware, do the scan or pairing or whatever, then upload another firmware and do the other technique. Or simply integrate both of the firmwares into one, and that's not really going to work because the one is C code, the other is mostly C++, and the Matter application development SDK doesn't really support native or open thread access, so the thread API is not there. NFC antenna, as I mentioned, if I add the NFC antenna and tune it properly and it works, then I could use it for easier Matter pairing. Some electrical protection for the PCB. I figured it out that if I connect my device on the fly, then it might or might not work. Because of power surges, my Flipper Zero's SD card could get damaged, like 3 times it did. And then, so it needs some modifications, some capacitor would help, and some protection is needed. 5-volt connection could also be useful for my use case because the thread radio might need a bit more power to work properly. And the challenges. I don't want to read this slide. I put it here because it's interesting and it might help someone to figure out what the issues are with developing a firmware for a radio device. Essentially, the pain point was debugging, figuring out how to debug, then figuring out what different debugging options are available for you. For example, in Zephyr, step-by-step debugging was possible. You set a breakpoint, and then you stop there, and from there you do a step-by-step debugging. That's helpful in one issue. But if you have a more complex issue, it's really painful. Then I started to update the different SDKs, and Swagger did implement the proper debugger in Zephyr, and it started to work. That was nice. Also, as I mentioned, there are 4 different thread versions in the market currently, so you need to choose which one to use. And when you start to create a Zephyr application, it's a pain to configure it. Like, they created a framework that can be configured essentially command by command. So if you don't need something, then you don't enable it. But they did not provide the functionality to fail meaningfully. So if you write a command and you are trying to use it, then it will fail at build in some cases. But there will be no reference to help you. There will be no help to figure out what specific config parameter is needed for that one specific thing. And then if you enable something, that could broke some other things. For example, there is a TCP implementation in OpenThread, and there is a TCP implementation in Zephyr. If you enable both of them, it won't work. But the configuration environment is not really providing any help with that. I did chat with the Zephyr engineers, and they mentioned that, don't use it. That's it. So choose one and choose the proper one. Also, G-Link debugger, if you start to develop something on your Flipper, I highly recommend the Swagger's G-Link debugger. It saved my ass multiple times. And also, the Wi-Fi board, the extension board, contains a debugger chip. It also could be used if you can figure out how to connect multiple extension cards to one GPIO port. I figured that you could extract some pins and then connect it directly to your Wi-Fi board, and then via that Wi-Fi board and UART, you could debug the Flipper Zero. It's a bit complicated and it's a mess at the end. But G-Link worked much better for me. Also, the MGS library that is integrated in Flipper is rather limited. Like, it's 50 kilobytes of JavaScript interpreter, 1 kilobytes of RAM, and most of the useful stuff in Java is missing. So, for example, if you would like to concatenate 2 strings, then you need to write that. If you are willing to convert your numbers to a string, then you need to write that. And some more fun stuff. So it's painful. And that was mostly it. I did put there some links.
Thank you, Andras, for the. And we'll open the stage for questions. You can ask your questions now. Anyone? There you go.
Hi. So doing this on a Flipper 0 sounds extremely painful. So what was the decision what made you decide that you want to do this on a Flipper rather than just plugging this USB drive in your laptop and writing a Python script? Like, what is the benefit of this running on the Flipper?
You could not really create a presentation based on one UART cable. So you need to add something that rings the bell for most of the people. And also, I wanted always to create something that can be integrated to my Flipper, because I tried to find use cases where I could use my Flipper 0, like cloning a hotel card, that's a use case. But this is a more meaningful use case. And originally I wanted to interact with the network without connecting something to my laptop.
I see. So it's basically without the Flipper would have been too easy.
Yes.
Any more questions we have? Back.
There.
So this is not a question but more of info sharing. Wanted to understand that you had a journey while implementing this Flipper 0 project. You may be exercising more of these projects in your time. Is there any structured approach which or any book or any blog which can be followed to take up this further?
There are examples and solutions how you can implement a thread application. There are others how you can implement something for Flipper, and those are outdated. So if you buy your device, it runs a version of firmware. If you start to develop something, you had a great idea to update it, then half of the APIs will be broken and it won't work. I updated my Flipper 0 2 weeks ago just to check what they implemented, and they totally have rewritten the JavaScript implementation. So none of my code did run. And I think it was 2 release or something, 2 minor release, not major ones. So there are documentations, there are solutions, there are examples, but most of them are outdated. And the documentation is laggy at best. So, for example, the Blackmagic debugger in the Wi-Fi board is not documented. There is no explanation what pins are used for what reason. And you can figure it out if you open up the firmware or if you open up the application, then you can extract it, but there is no clear documentation. And everything is constantly changing. They update all the different components and everything is interconnected. So, more often it's broken than not.
One more question we can take.
Aside from a Flipper 0 and aside from a laptop, what other devices do you recommend for using for development for this purpose?
Sorry, could you repeat it a lot better?
Can you hear me? Aside from using a Flipper 0, what other device would you recommend, like a ESP32 board or what exactly?
ESP32 also supports this, so I could choose the ESP32 chip, but I started before I figured it out that I want to integrate with Flipper with the Nordic chip. The ESP32, it's essentially is the same, so there is a UART, you could use that as well. There are ESP32 chips that supporting this. I think the Edge variant is supporting the thread network, so you could use that as well. It depends on your preference.
Any more questions? Okay. With that, thank you so much, Andras, for this insightful session, and I must say an interesting presentation as well.
Thank you.
And can we again give a big hand to Andras?